All right, so yeah, welcome to class, everyone. Like I was saying, we're going to be teaching on SQL today. I've got some slides for us, and then we're going to actually get into the program and see how everything works. I am going to turn off my camera so you guys can just focus on the presentation for now, and then I'll come back on camera in a little bit. All right.
Mhm.
All right. So SQL, structured query language, such an important you know, uh, program and opportunity here. I really want to take some time at the beginning of this lesson to stress the importance of being able to learn this. A lot of people have heard about Microsoft Excel, and it's important and it can help you, open up opportunities and things like that, which is true. But there's also SQL. And SQL is really important if you're ever going to be working with large amounts of data. And when I say large, I mean tens of thousands, hundreds of thousands of rows, maybe even millions and billions of rows of information. So
Mhm.
think about things like every order that's ever been submitted to Amazon. Think about things like um, every uh, every IP address that's ever happened on a phone network, every address that has ever received a package from the postal office. Things like that there's big numbers that we're talking about. And
Mhm.
generally speaking, to get intelligence from that information, the only way to do it is using something like SQL, where you have a structured query language, query meaning to ask a question. So it's a
Mhm.
structured way of asking the computer a question. And then as you learn the language of asking the question, the better you get at the language, obviously, the better it can answer that question because you're asking it properly. So that's kind of the context of what we're going to be talking about today. I do want to make sure we have a lot of time for sharing examples and making sure that you guys have a decent understanding of the basic syntax. This is not a class that's going to get you to become an expert at all, but it will give you a foundational understanding of what it is and why it's important, and hopefully spark some interest for you all to take some time on your own to find some courses out there. There's courses on SQL on Udemy. I'll put that in the chat here in a second. And they're also on things like Coursera. So if you go to Coursera or Udemy, I just put them in the chat. Both of those
Mhm.
places have various different courses that are made available to the public for small purchase, like usually less than $100 is a pretty good course. And I think that you're going to find that it's well worth it because it's just going to introduce you to some technical skills, skills that are sought after by employers in the marketplace today. And there's just not enough people that know how to do it. So we'll go ahead and get started. All right, so what is SQL? So SQL stands for Structured Query Language. It's a standard programming language specifically designed for managing and manipulating databases. So what is a database? A database is just a collection of tables. And as you guys know from our Microsoft Excel class, a table just holds rows and columns of information. Think about things like, a table at, let's say you own a small business, you have a table that has all your customers in it, right? So row one would be customer one, their name, their email, their phone number, maybe their address, and maybe what else might they have? Maybe like some information about their computer. Row two would be customer two, row three would be customer three, and so forth. So you have a row for each unique customer. So that would be a table, but a database holds multiple tables. So um, often that data might be related. So you might have one table that has all of your customer information. You might have another table that has all of the orders. You might have another table that has all of the addresses, another table that has all of the payment instruments and the credit cards and so forth that folks are using. And you have all that data there, and you can ask it questions to gain intelligence and get to know your customer. So there's a term out there in business known as KYC. So KYC stands for Know Your Customer. So know your customer, KYC. And what that means is businesses want to understand as best they can from the data that they collect from you, as much as they can about your lifestyle, who you are, what do you like to do, at what time do you like to do that thing, because all of that is information that they can sell to companies that want to sell you products, honestly, right? Anybody here has ever used Instagram, you probably know that if you talk enough about things that you want, a vacation you want to go on, all of a sudden you get an ad for it. You're like, how did that happen? Well, because a lot of the times, Instagram and WhatsApp and some of these things that we use, they're listening to what we're talking about. And then it can send that information to an advertiser who then sends you an email because they know that they just heard you talking about wanting to go on that vacation. And so all of these companies here on the slide, and these are just a few of the big ones, I would say that every major company in America right now that has data, they're using it to gain intelligence and to know their customer. Because the better they know your customer, the better they can serve their customer. They know if their customers, want to shop in the middle of the night when their kids go to bed, or do they want to shop in the middle of the day while their kids are at school? Like they gain intelligence about all these things. And then they can make business decisions to satisfy that. So companies like Google, they do that. Amazon. I would say Google and Amazon are probably two of the biggest data companies out there right now. And they use that data again to know their customer and also to sometimes even share that information and with other third parties that want that information. Microsoft, WhatsApp, and Facebook, right? So these are all companies that are collecting a ton of data, and they use that data to gain intelligence. Okay, so why is SQL important? So as you can see up here in the top right-hand corner, I just have a really small sample table of made up data. And you can see I have like customer ID is the first column. The next column is first name, last name, email, phone number, the date the account was created, and the city where the customer lives at. So again, a table is just a way to organize information that is related. How is all this information related? They're all customers of the same company, right? They all have phone numbers, they all have city that they live in, a last name, a first name, etc. So this is a good table, but imagine again, you're working at a large company. If you have a small business, yes, you can probably have a spreadsheet that has all your customers on it. It might have 1,000, maybe 2,000 on it. But as you grow that company, and maybe you now have 2 million customers, because you never delete a customer ID. If they bought one product from you, they have a customer ID. So 2 million, customers over a 10-year period is not unfathomable, but that's going to be a very large spreadsheet, and it's probably not going to work in Microsoft Excel. So you're going to have to convert to a database, and then to get information from a database, you need something like SQL to extract information exactly what you want. Because no one really wants to look at all the information. You normally have a question, and managers at companies always have questions about data. And so let's look at what some of those questions are. Like right here, you see, are our new customers this month using the new customer discount to get the 10% off, right? So let's say you're a company and you have a discount for new customers and I'm sorry, and you put the deal out, but then you want to assess how useful it was. Did it work? Did the new customers use it? Did they like it? How do you assess that? You have to write a SQL query and say, show me all the new customers, and I want to see from those new customers, how many of them use the 10% discount. Maybe you want to see, hey, database, how many customers do I have that live in Auburn versus Seattle? Why might that be important to a company like an Amazon? Do we have more customers in Seattle or Auburn? Well, that will be important because let's say they're trying to figure out where they want to put their next fulfillment center, which is, the places they ship the packages out. Obviously, they want to place fulfillment centers closer to the largest amount of ordering customers. And so it would be important for Amazon to know where are most of our customers, and especially where do we have a lot of customers and there's not a fulfillment center close to them. Well, you can write a query in SQL to answer that question. Because again, it looks at all the data of all the customers, and it'll say, hey, you got a lot of customers in Auburn, and their closest fulfillment center is maybe 25 miles away. If we place one closer, we can serve them faster, we can get their products there faster, we're going to have better customer service in that area, and so forth. So these are all very important things. And this is why SQL can be really important. Maybe you could even say how many new customers registered last month. That could be an easy query that you could also write. What state did we have the most sales in? These are all business questions that big companies are honestly asking themselves every day, all the time. So if you know anyone that works at a tech company, or you've heard about people that are working at tech companies, you might say, well, okay, that sounds all good, but I don't think I could do that. But you can, and that's why I want to introduce this class to you all. And the job that would do stuff like this and in SQL is called a data analyst. So data analysts are really good at understanding data and then gaining intelligence from that data, because raw data isn't really useful, but once you like collate it and look at it and understand what it all means, then it really is intelligence. And that intelligence drives a lot of business decisions at a lot of large corporations these days. You know, if you think about a company like a Chick-fil-A, and they're thinking about where to put their next restaurant. Have you ever noticed that Chick-fil-A's and McDonald's are always on the best corners? That's because they do a lot of data studies, and they use data to understand, hey, we probably should put the Chick-fil-A on the side of the road where people have to pass going home. They don't want to put the Chick-fil-A on your way out, because not a lot of people are going to eat Chick-fil-A at 6 or 7 in the morning on their way to work. But boy, when you get off late and you're tired and you don't want to cook, and oh, you got to pass that Chick-fil-A on the way home, that is data that they have where they know a certain amount of people are going to stop and they're going to buy Chick-fil-A on their way home. They know that 10% of the traffic is going to stop. So if I put it on a very popular road, 10% of those people are going to pull over and get Chick-fil-A that night, right? So again, they're using data that is then becoming intelligence, and then that intelligence is then driving business decisions, big business decisions, right? Like where to place facilities and employees and things like that. I'll take a pause. Does anyone have any questions at a high level of what SQL is before we get into some of the nitty gritty and go into some examples? Everyone
Mine is
good?
not an example, it's just a comment because, like, as you talk about the Chick-fil-A, and I'm just looking at the one in Federal Way, it's literally situated at 320th and Pacific Highway, very
Mm-hmm.
conveniently. So, yeah, that's
Oh, yeah.
okay.
And that's because someone did a traffic study and said this is going to be the best location that is available for us to put a Chick-fil-A. I'm sure they probably surveyed 10 or 15 spots, and based on data, traffic patterns and things that they study, they figured
Yeah,
that that was going to be the best location. And it is. It's always packed, right?
absolutely.
And the same
Yeah,
thing.
always, always,
Yep.
always.
Yep, and they even do data studies on how placing one Chick-fil-A can affect another Chick-fil-A, right? You don't
Mm,
want them to be too close, right? So there's one in Lakewood, there's one in
yeah,
Tacoma at the mall, there's one in Federal Way, but they
yeah.
place them strategically just far enough away from each other so they also don't take business from each other, right? So
Wow.
all important stuff to consider. Okay, let's go into some details. So let's look at what the basic syntax, and the syntax just means the basic structure of how to write a SQL query. So again, the database that we're going to be using today is called DVD Rental One. So in this example, we have a database that includes information about a company's DVD rental business. And so within their database, remember, there's multiple tables. So some of the tables we're going to look at today is a table that has all of the DVD rental business's customer information. There's going to be a table that has all of the information on the films that they have available for rental. And then there's going to be a table that has all of the payment information, right? So every time a customer comes in and buys something, that's going to get stored in the payment table. And then the customer is going to be here, right? Also, normally there would be an orders table, there would be a table with all the addresses, etc. But I just want to demonstrate just using these three tables today some examples, some basic examples of how SQL works, and some questions that it can answer for you. All right, let's go ahead and go into it. So here's your basic SQL syntax, okay? So select star is going to give you, so again, remember, looking at tables, tables are structured in columns and rows. So select star tells the query, I want you to give me all the rows that we're looking at, and this, or I'm sorry, all the columns, and we'll look at this, and this will make sense in a second. You have to tell it from which table. So to go back, right, or do you want me to give you information from the film table, the payment table, or the customer table? So that's what this is referring to here, where it says from table one. And then you need to give it a where condition, maybe where customer ID equals 1, because you only want to see customer one's information, or where customer ID equals 1 through 10, if you want to see the top 10 customers, something like that. Here, another example, just to break it out, is you can also just name the columns that you want. So select star will give you all the columns available in the table for the rows. If you do select and then give the column names, it'll only give you those columns that you name from the table, and then whatever the where condition is. So let's take a look at an example to hopefully make this make some more sense. So again, select star. So that again gives you all the columns. So what are the columns available in this table? It might be a little small, and I apologize, but I wanted to have a good demo here. So what columns are available in this table? Customer ID, store ID, first name, last underscore name. Notice, by the way, when we're looking at the names of the columns, there's no spaces. So where you have last name, it's always going to be last underscore name. Same thing we're here. First name is first underscore name. Customer ID, customer underscore ID. Because you in a column name, you cannot have an actual space. So that's very important. No spaces are allowed in a column name. And so these are all the columns here along the top for this particular table. What is the name of the table that we're looking at? Customer, right here. Okay. So we did select star, because I want all the columns from the customer table. And then we hit the execute button, it executes the query, and it tells us here at the bottom left that we have 599 rows of information, meaning that this particular company has 599 customers. All right, now here, we did it a little bit more. So remember on this slide, we did select star from customer. So now we took it one step further, and we are just breaking out and saying, actually, I don't want all of the columns. I just want first name, last name, email, and create date. So here you can see it doesn't have all the columns across the results here. You still have 599 rows because you are selecting all of the customers, but you're only getting 4 of the columns now. First name, so see how I spelled it up here? Select first underscore name. That's the name of that column. If I didn't have the underscore here, then this would not show. Okay, so it's very important that when you list your columns that you want in your query results, it's important to write them correctly. If you don't, they won't work, right? Because it is a computer. It can only do what you tell it, but you have to be correct. So it is pretty sensitive, I would say. So first name underscore, last underscore name, email, and then create date from the customer table. And you get all of the data on the 599 customers. Any questions on the basic syntax before we continue? No? Okay. All right. So again, now we're adding one more piece. Again, so we have the select clause, and the select clause specifies the columns that should be returned in the query. It's essential for determining what data to retrieve. So select star will retrieve all columns. So we talked about that. We know about that now. The from clause is what table do you want to grab it from, right? So it's crucial, obviously, to grab from the correct table. If you want customer information, you got to be grabbing from the customer table, not the payment table. And then lastly, we're going to add now the where clause. So the where clause is going to pare down even more what results you get. So if, for instance, the where clause here, I said where active equals 1. So what is that going to do? That's only going to return active customers, because in computer language, the number 1 stands for true and the number 0 stands for false. So where you say, so if there's a column, let's go back up here again. So let's see. I don't see it on this particular one. It looks like I probably ran out of space. But bottom line is, if active equals 0, that would mean that that customer is inactive. If active equals 1, that means that that's an active customer. They've been purchasing at a regular basis. So again, if a CEO of a company wanted to see all of their active buyers, this is all the query that they would have to do. Just select star from the customer table where active equals 1, and it would return all of the active customers. Okay. The last thing I want to add here is I want to add order by. So let's look at what that does. So if I do a select star from customer and I do order by customer ID ascending, what does the word ascending mean? If you put something in ascending order, what does that mean?
Starting from the bottom to the top.
Yeah, it means going from the lowest value to the highest value.
Yes.
So if I put letters in ascending order, it's going to start with A and it's going to finish with Z, right? So same thing, if you do ascending order with numbers, it's going to start with customer ID 1, like we see here. Okay, so I put the customer ID in ascending order, ASC, so that means ascending. So I'm getting all the customers, but I wanted to put it in order by customer ID. So customer ID 1, 2, 3, 4. And then I reversed it, and over here on the right, we did same query, but we did order by customer ID descending. So what does it mean to be in descending order? That means to be in highest to lowest order. So again, we know we have 599 customers. So what order did it put it in? 599, 598, 597, and so forth, right? And I just have screenshots of the query here, but it would have all of the orders or all of the customer IDs, but now in reverse order. Okay. So that can be very useful if you want to like look at all your customers and see who your customer is that orders the most from you. You might want to like add up all your customers' orders and then look at them in descending order, because that's going to give you your highest customer purchasing at the top, and you can get like your top 10 customers, right? So we'll take a look at that actual example here in a little bit. Let's go ahead and move over to PG admin, and I'll share my screen. So this here is just some basic SQL commands. Primarily today, we're just going to be working in these 3 areas. You can see that there's a lot you can do in SQL, but we're going to be primarily looking at the select star or select column 1, column 2 from a table, or even adding in some order by ascending or descending and with some where conditions. So we'll stop there today, but I just wanted to put that out there that there is a lot to learn. Okay. Query the list of customers. I'm going to go ahead and switch over my share screen so you guys can see my other screen, and we're going to do some examples. All right, so you guys should see my screen now. Let me close this all out. Don't save. Okay, so I'm going to go here, and I'm actually going to go ahead and open up my query tool. Okay, and then I'm going to go here, and I'm going to look at all the tables. So the first thing I want to show you guys is the tables that we have. So notice, so this is the database we're looking at, DVD rental 1. I don't want you to get confused with all the stuff on the left. Don't worry about it. The main thing is we have a database here, and then down here we have all the tables that are in the database. So we have a table for the actors that are in the films that we have. So if someone came into our store and said, hey, I want to see all the films that have Michael Jackson in it. I could go to the actor table and I could say, hey, show me all the films we have in inventory where the actor name is Michael Jackson, and it would return a value on that and say, here's all the films. Same thing with addresses. Here's all the customer addresses. Category, these are the categories of the different films. The cities where our customers live at, the country where our customers live at. This is the customer table. As you can imagine, every large company has a customer table with all the information on every single customer. It's the reason when you go into Fred Meyer, they want you to put in your phone number before you purchase, because they want to be able to track all of that specific customer's orders. And the more, again, that they get you to log in using that, that gives them solid data that can tie those purchases directly back to you. And then again, they gain more intelligence about when you like to shop, what do you like to buy, what type of things do you not buy, what time of the day do you come in? Do you come in before dinner, after dinner, on the weekend? Because all of that allows them to also figure out staffing needs, right? If they know a lot of people come to the store between 5 and 6 p.m. because they're on their way home and they got to stop for something for dinner, that allows them to increase the staffing during that time. And they have real data to support that that need, right? They don't just feel like a lot of people come in. They can actually go look at the data and say, oh yeah, sales went up 25% between 5 p.m. and 6:30 p.m., right? So therefore you can, again, just kind of manage your internal employees, make sure you have enough staff. So we have all these different tables here today. We're primarily going to look at customer, payment, and maybe we'll look at rental too. It kind of depends on how far we go. So again, we want to do a query just to look at all of our customers. So I'm just going to open up this customer table here. And here you see it says columns under customer. These are all the columns in that table. So customer ID, store ID, first name, last name, email, etc. All the way down to active. So to get a list of all of our customers, we just, again, need a select statement. So just select star. And then from customer. How do I know the name of the table is customer? Is right here. So it says customer. So if I put customers and I try to execute the query, it's not going to work. So it is important to have everything nice and tight. So I put customer, and now you can see the query results here. And we have all of our customers. Customer ID 524 showed up first though. So let's fix that. And let's go ahead and do a order by customer ID descending. Now I'm going to put it in descending order because let's say your manager came to you and said, hey, what's our newest customer? Like, who are they? Where are they from? What's their email address? Whatever. And what date was that created? So because I put customer ID in descending order, right? So I have 599 at the top and it's in descending order by customer ID. Now I can see that my newest customer, his name is Austin Clintron. This is his email, and his account was created on this day, 2/14/06. Any questions on that basic syntax? Again, I just want to take a pause and give you guys a chance to ask some questions. No. Okay. Is this making sense? You guys got to say something. Got to give me a little feedback.
It is making sense.
Okay.
It's just that we're not able to see properly because the writing is too small. But
Okay.
but we understand what you're trying to explain.
Let me zoom in.
Mhm.
Let me zoom in. I want to make sure you guys can see good. So let me just continue to zoom in a little bit. Can you see now? Does that help? Does it look a little better now?
It is a little bit better, yes.
Okay. Okay. So again, I just did select star to get all the columns from this customer database. And then I told it to order by So put it in order by customer ID, but in descending order. So that's a pretty basic query there that we can do. Now, let's say that I don't want all of the columns, because see here we have customer ID, we have store ID, first name. Let's just say I want to get just the first name, last name, and email address, because I want to write a email to all of our customers. So I just need their names and their emails. So instead of select star, we would do select first name, last name, and then email. So now it's just going to give me these 3 columns instead of all the rest of these columns. So I'm not going to even get customer ID. So I can actually just, to make this not active text, but if I don't want to delete it, because maybe I want to use it later, I can put 2 dashes in front of it and see how it turns it green. So that's going to make that inactive text. So now it's only going to read this text. It's not going to read this text here now. But if I wanted to use it again, I can just come get rid of those 2 dashes, and now it makes it live again. So I'm going to leave those there. So we're just going to get first name, last name, email from customer. Boom. So we run it, and now we only have 3 columns. So we got first name, last name, email. Okay. So pretty easy. And that's how you would get just the columns that you want. We can order by anything. So we can actually even order by multiple things. So we could order by last name and then first name. So what would that do? So let's say you had 15 Smiths, right? So it would put all the Smiths together, but then it would go to first name and then put them in alphabetical order, right? So again, keeping your list organized. So it said order by first name, last name. Oh, sorry, last name, first name. So it went with Abney, which is the lowest last name we have, and then Raphael, Adams, and then Adams and Adam. Let's see, Andrew, Andrews, etc. So it puts it in alphabetical order, and it works really well. Okay. Let's say you wanted to, I'm going to go ahead and get rid of this for a second. Let's put in a where clause. So let's go with a where clause now. So let's say that we wanted to put in a where clause that was going to just grab just a certain kind of last name, right? So let's say a customer came in and they said, hey, my last name is Smith. I forgot my customer ID. Can you help me find my customer ID? Say, no problem. And what's your first name? And they're going to give you their first name. And then you can say, okay, write a query here. And I'm going to just go with select star again from customer. But this time I'm going to say where last name equals Smith. Notice I put the little single quote around the word Smith. That tells it that it has to match exactly to those words. So if I go ahead and hit play here, we only have one customer with the last name Smith. And what's her first name? Mary. Oh, and she happens to be customer number 1. So there you go, right? So that's a way to find a particular person within your data set. Maybe they said, hey, my last name starts with BA, right? So if that's the case, now you have to use the % and you have to say is like. So if you know that their name starts with BA, but you don't know what's after that, you can just come here and put where last name is like, so I like, and then the single quotes with the BA and the %. So now let's see our results. So we got a couple results. So we have several customers whose last name starts with BA. We got Baker, Bailey, Barnes, Banks, and there's, 15 different rows here. So there's 15 customers whose last name starts with BA. So do you guys see what that % does there? That's what we call a wildcard. So a wildcard means it can be any number of characters. As long as it starts with BA, anything else can be behind it. Okay. Now, let's say they came in and said, my last name is BA, and then they like, for whatever reason, don't remember what's here. They know it starts with BA and ends with ES. So here you go. So this character, the underscore, represents just one character, right? So there you're going to get anything. It could be Bates, it could be Bales, like you see here. So again, because this underscore just represents one character. So if they just don't know one character, there you go. That's how you could search that up. I'm gonna pause again, see if there's any questions. I'm gonna just green that out. And let's go look at another data set. So now I'm going to look at I'm going to look at all the categories here. So let's do select star from category and see what our data looks like. So from category, I have all the category IDs and the name. So I actually have 16 different categories, right? So category 16 is travel. So movies about travel. Category 7 is drama. 3 is children, etc. So that's pretty easy table. It just has all the categories for all the films. Let me let somebody back in. Let's go explore some of the data in the actor table. So again, let's look at all the data in the actor table. So what do we have here? Actor ID, and then the first name and the last name of that actor. Okay. So why might that be important? If someone comes in and again, they want to see what films do you have that has Ed Chase, right? So let's see, Ed Chase. So he's actor ID 3, right? So let's do select from actor, where first name equals Ed. And these are all the actors named Ed that we have films on. Okay. Let's go take a look at our payment table. Just going to do some simple queries here. Again, under our payment table, we know that these are the columns. So we have payment ID, which would be the ID for every specific payment that was made to the company would have a payment ID. So that would be what we call a unique identifier. So every row in the table would have a unique payment ID, right? So that if you ever, it'd be like having a receipt with your receipt number, right? There's only going to be one receipt that has that unique number on it. So same thing with payment ID. So let's take a look at the payment table. So how many payments has this company received? Because we did select star payment, 14,596. Now, maybe the owner of the company said, hey, we have 2 employees. So you have staff ID 2 and staff ID 1. And maybe the owner of the company says, hey, I want to know which employee had more payments that they collected. Was it employee 1 or employee 2? So what you could do in that particular case is go here to customer ID. So you would select, select staff ID, and then sum the payment ID from payment. And I would say group. So this is a new function, group by staff ID. And then I'm going to do order by sum of payment ID. Let's see if this works. All right. Payment ID. Oh, count. Sorry. Count. Did the wrong function. Just do count. Okay, there we go. So here we have a results of a table. So the manager asked us who took more payments, staff ID 1 or staff ID 2. And according to our query, we said, I want 2 columns. I want the staff ID, and then I want a count of how many payments each one took from the payment table. And then I did group by staff ID 1. So what does that mean? That means it's going to take all the payments where staff ID 1 is there, and it's going to group all those together. And it found that there were 7,292 payments taken by staff ID 1. And then staff ID 2 took 7,304. So again, very, very easy to just run some basic numbers and say, oh, staff ID 2 was our top sales manager, because you just ran a quick query that told you who had the top sales. Companies do this all the time. Fred Meyer, whoever, hey, this person had the fastest checkout times at the Fred Meyer store in Covington last week. How do they know that? Because you go to your register, you sign in, and you start scanning. And it has scan times, and there's data that some analyst is looking at in a building somewhere saying, oh, this person had the fastest scan time in the store last week, and they get a reward or a cookie or a Starbucks gift card, whatever it is. But they're using data to encourage people to work harder and move faster because they know that they're being tracked, right? So that's one example of where you would use what we call an aggregate function, where you can count or even sum. So another thing we could do, so here we counted, let's do a sum of amount. So we also could do sum of amount. And here you can see that staff member 1, if you total up all the payments they took, it was 31,000. Staff member 1 took in 30,252. So I just changed the what we were looking for. So initially we were looking at count of payments taken. This time we were summing those payment amounts, right? So $7.99 order, a $10.99 order. So we're adding all of that up. Okay. Let's see. This also has customer ID. So I want to show you one last thing before we run out of time. It's 6:53. I want to show you a join. So notice here, I'm going to get rid of all of this. Just going to get rid of everything. So let's say, again, we go here, select from payment. Okay. So we know here that customer ID 341 has a bunch of payments. We can see that this same customer has a $7.99, $1.99, etc. So let's say you wanted to find your top customer. You could just do select customer ID, sum amount. And you could do group by customer ID, order by some amount, and then do a limit 10. Order by some amount descending. So this is going to give you your top 10 customers. So here you can see your top customer based on the data we have is customer 148, and they spent $211.55. Customer 526 spent 208, 178 spent 194.61. So again, you can use the technology to figure out which customer is your best customer. Okay. Okay, perfect. Let's say you wanted to bring in the customer's name and email because you wanted a complete list, because all you have here is customer ID. And that's okay, but maybe you want to actually see on the same table results, I want to see the customer ID, their name, full name, and then I also want to see their email address along with this number. So that's where we have to do what we call a join. So I want to delete all of this. And I'm going to do select, and I'm going to do from payment. I'm gonna call that P. And then from here, we want P dot customer ID and P dot, let's see, amounts. So we're gonna sum it. And then we're gonna do C dot first name. And you'll see what I'm doing in a second. C dot last name. C dot email. Boom, boom, boom. And then I'm gonna enter join customer on P dot customer ID equals C dot customer ID group by P dot customer ID order by this descending limit 10. We'll see if I did the code right. Oh, messed up something. Let's see. C dot first name, select payment, enter join customer C. 1 second. Group by P dot customer ID. P dot amount. Oh. See if I can get it to work here. Customer, where's my customer on? Customer ID. C dot first name, last name. Let me get rid of this for a second. Let me just try something. Okay, so here we got it to work. So what did I do here? I just brought in, I'm gonna actually do P dot star. So here I brought in, for every payment, right? We have like a customer ID right here. But I also brought into this table now the customer's first name, last name, and their email address. So now we can see, not just because the payment table only had customer ID, it didn't have their name. So you can actually join tables to bring in additional information so that your data is more complete. And that's what we did here. So we looked at all of the columns from the payment table. So that's why I did P dot star. And then I brought in only 3 columns from the customer table, which is why we have, if we go down, we have order here from customer 343, and then there's their email and stuff over there. I can do limit 100. It'll bring in 100 orders. If we don't have a limit, it'll bring in all the orders. Okay. So again, if I scroll over, we got the name and the email address related to each one of those payments. So I'm going to pause there. It is 6:59. Are there any questions? Is there anything else I can explain?